This is going to be a short video on wavelength and frequency requested by Jeffrey. So our first question, a radio station broadcasts at 1240 kilohertz, and what are the wavelengths of these radio waves? So right away we should see that this is in kilohertz, and we should change that to just hertz. So KHZ, then converting it, it's 1 hertz per, it's 1000 hertz per 1 kilohertz. And that gives us, in scientific notation, 1.24 times 10 exponent 6 hertz. Now that we have this, we should use we can just plug the rest of our information into the formula, which is C equals lambda, and then this symbol, which looks like a V, it's called mu. And then in this question, it says, what are the wavelengths? Lambda represents the wavelengths, C is speed of light, and nu is frequency. So you can rearrange this to solve for lambda equals, and that would be C divided by nu. C is the speed of light, which is 3.00 times 10 exponent 8 meters per second, then divided by the frequency, which we just did here, 1.24 times 10 exponent 6 hertz. Then, well, actually, hertz, 1 hertz is equal to second exponent -1 per second. So if you write that here, so -1, and also change the meters per second into meters times seconds exponent -1, you can see that these two cancel out. Then we know our answer will just be in meters, which is good because it's wavelength. So we take our calculator, 3 divided by 1.24. That gives us 2.423 sig figs times 10 squared meters, or 242 meters, and that's our final answer. So now for the second question. Some earthquake waves travel at a velocity of 5 kilometers per second. What is the wavelength of such waves if they happen at 10 per second? So this one is a little bit different. We can't use this formula anymore because it is not a wave of light. It is not electromagnetic radiation, and it moves at a different speed. So we have to make our own formula. We can still have lambda and nu, but we can't have C. So let's just change that to V for speed equals lambda nu. And then what we're given is 5 kilometers per second, so we should right away change that into meters per second. So 5 kilometers per second times 1 kilometer and 1,000 meters. Oops, 1,000 meters equals 5,000. 1 second. 5,000 meters per second. Then we also see we have 10 per second, and per second is the same as hertz. So that would be 10 hertz, and that's our unit for frequency. So let's rearrange our formula. We're looking for, what was it? Wavelengths? Yeah, wavelengths. So we have lambda equals v over nu equals our v, which was 5,000 meters per second, divided by our frequency, which we had 10 per second, so 10 s exponent negative 1. And these are both per second, so we can cancel them out. And it'll leave us with 500 meters for our wavelengths. And then the final question. It takes 7.21 times 10 exponent negative 19 joules of energy to remove an electron from an iron atom. What is the maximum wavelength of light able to do this? For this one, we need to use another formula and also Planck's constant. So our second formula is E for energy equals H times nu. And then so right now we have an amount in joules, and our unit for energy is joules. So this is our energy, and we also, I should write this down here, Planck's constant, H is Planck's constant, and that should be given to you. It's 6.62262 times 10 exponent negative 34 joules times seconds. So now, since we have E and H, and we're looking for lambda, here, let me put down the other formula here too, equals lambda nu. What we can do is solve this equation with our E and H for the frequency nu, and then plug it into this equation and then solve for lambda. So we'll start with the first one, solving for nu, so it's nu equals E divided by H, so 7.21 times 10 exponent negative 19 joules divided by Planck's constant, which is 6.6262 times 10 exponent negative 34 joules times seconds. So the joules will cancel out, leaving us with seconds on the bottom, which is the same as hertz, which is good because we're looking for frequency. So now we just put this in, and it gives us 1.09 times 10 exponent 15 hertz. Let's underline that. So now that we have that, we can plug in our numbers into the second formula. C equals lambda nu. And then, but we're looking for a wavelength, so lambda equals C divided by nu equals 3.00 times 10 exponent 8 meters per second divided by 1.09 times 10 exponent 15 seconds negative 1. Can cancel out the per seconds. Then that leaves us with calculate this, and you get 2.75 times 10 exponent negative 7 meters. Yeah. Okay. And that's it. Thank you.